Hi everyone, in this video we are going to see how to find the equations of the tangents with a given slope. Let's suppose we have a circle like this whose equation is x squared plus y squared plus 2gx plus 2fy plus c equals 0. Obviously the coordinates of the center would be negative g comma negative f. Now if we are given the slope of the tangent line, how many tangent lines can we draw with the same slope? Well, actually we can draw two tangent lines. As you can see in the diagram, we have two tangent lines where the points of contact are P and Q. P is the point of contact for the tangent line whose equation is y equals mx plus b sub 1, and point Q is the point of contact for the tangent line having equation y equals mx plus b sub 2. In both the cases, they have the same slope. That means those two lines are parallel lines, but they have different y-intercepts. So I have taken the equations that way. Here the given information is the equation of the circle, from which we can find the coordinates of the center as well as the radius of the circle. And also we have been provided with the slope of the tangent lines. Now from this information, we have to find the equations of the tangent lines, and also we have to find the coordinates of the points of contact. If we join the center with the points P and Q, then PQ will actually become a diameter, because P and Q will be on the diametrically opposite ends. Since the two tangent lines are parallel, PQ will be on the opposite ends of the diameter, and clearly CP will be equal to CQ, and each of them will be equal to the radius of this circle. Let me denote that with a lowercase r. Now from the given equation of the circle, what would be the value of r? Well, we know that r is equal to square root of g squared plus f squared minus c. Because we have been provided with the equation of the circle, we should be able to calculate the value of r. And also we have been provided with the slope of the tangent lines. Let's assume that the slope is m. So in the two equations of the tangent lines, the unknowns are essentially b sub 1 and b sub 2. Now if we take a generic equation for the tangent lines, let's suppose the equation of the tangent lines is like this: y equals mx plus b, where b is the y-intercept and m is the slope. And if we rewrite the equation, we can write it as mx minus y plus b equals 0, which is in the form ax plus by plus c equals 0. That's the equation of a straight line. Now we are going to try and create an equation from where we can find the two different values of b. One value will be taken as b sub 1 and the other value will be taken as b sub 2. That means we are looking for an equation that will give us two possible values of b. Now what can we do? Well, we can create an equation like this. We know the distance from the center to the point of contact will be equal to r. Now what would be the distance of the tangent line from center? Well, we can write it like this: absolute value of m times negative g plus negative 1 times negative f plus b over square root of m squared plus negative 1 squared. M is the coefficient of x, negative 1 is the coefficient of y, and here I am simply using the formula of distance of a straight line from a given point. So using that formula, we can say that the distance of the tangent line whose equation has been taken as y equals mx plus b, the distance of this tangent line from the center will be like this, and that is actually equal to r, the radius of this circle. And in the next step, if we multiply both sides by square root of m squared plus 1, then we can say that absolute value of negative m times g plus f plus b is equal to r times square root of m squared plus 1, because in the denominator you see that m squared plus negative 1 squared is nothing but m squared plus 1, and now we have multiplied both sides of the equation by square root of m squared plus 1. So now we have the equation looking like this, and this is an absolute value equation. If we remove the absolute value sign, then we can write the equation like this. From the left hand side I have removed the absolute value sign, and on the right hand side I am using plus or minus. So we have two possible equations here, and in the next step I am going to find the value of b. So you can say b is equal to mg minus f plus or minus r times square root of m squared plus 1. And from here, taking the plus sign, we can say b sub 1 will be equal to mg minus f plus r times square root of m squared plus 1. And then taking the minus sign, we can say the value of b sub 2 will be equal to mg minus f minus r times square root of m squared plus 1. So we have been able to find the two values of b. One of them will be taken as b sub 1 and the other one will be taken as b sub 2. The higher value, meaning where we are using the plus sign, that will be the higher value that will be taken for the tangent line which is on the upper side, and the lower value with the negative sign that will be taken for the tangent line which is on the lower side. So what will be the equation of the first tangent line then? Well, it can be written like this: y equals mx plus b sub 1, and I have simply used the value of b sub 1 here. So that is the equation of the first tangent line whose point of contact is P. And the equation of the second tangent line is going to be like this. It will be y equals mx plus mg minus f minus r times square root of m squared plus 1. Here I have simply used the value of b sub 2. So it is mx plus b sub 2, and in place of b sub 2 I have used mg minus f minus r times square root of m squared plus 1. So those are the equations of the two tangent lines. Now if you look at these equations, m is given, g is known from the equation of the circle, f is also known from the equation of the circle, r is also known from the equation of the circle. So we pretty much know everything, all the quantities, right? So we should be able to determine the actual equations of the two tangent lines whose slope has been provided. Next, we are going to take a special case when the center of the circle is located at the origin. In that case, what would be the value of g? Well, g will be equal to 0 because the x coordinate of the center would be at the origin, that will be 0 of course. And what would be the value of f? That will also be 0 because the y coordinate of the center will be 0 if the center is at the origin. So from here, the equation of the first tangent line will look like this: y equals mx plus r times square root of m squared plus 1, because m times g will become 0 and negative f will also become 0. So we are going to be left with just this, and the equation of the second tangent line will look like mx minus r times square root of m squared plus 1. The terms with g and f, they will become 0. So we are going to be left with the equations like this. When the center of the circle is located at the origin, these will be the equations of the two tangent lines whose slope is given as m. And if we write a combined version, then we can say y equals mx plus or minus r times square root of m squared plus 1. That is the combined form of the equations of the two tangent lines whose slope is given as m and the center of the circle is located at the origin. Next, we are going to try and see how to find the coordinates of the points of contact. I mean the coordinates of P and Q. To find the coordinates of the point of contact, we have to use the following steps. First, we will use the y value in the equation of the circle, and this will give a quadratic equation in x. Then we will solve for x. Actually, we will get two equal roots. That means we will get two equal values of x. And then using the value of x, we can calculate the value of y. And that way, we can find the coordinates of the corresponding point of contact. So now we know the equations of the two tangent lines, and we are going to use each of those equations to find the coordinates of the corresponding point of contact. The equation of the circle is like this: x squared plus y squared plus 2gx plus 2fy plus c equals 0. But when the center is located at the origin, then the equation of the circle looks like this: x squared plus y squared is equal to r squared. And let's take the equation of the first tangent line, which is y equals mx plus r times square root of m squared plus 1. And now I am going to substitute this y value in the equation of the circle. So wherever we had y squared, I have put that value, which is mx plus r times square root of m squared plus 1. Now if we expand the whole square, the equation going to look like this. Now if we simplify this a little bit, it's going to look like this. And here you can see the positive r squared on both sides will cancel out each other. So essentially our equation is going to look like this. And this looks like a quadratic equation in x. So we are going to find the two values of x. We can say x will be equal to negative b. In this case, b is actually the coefficient of the x term. So we can say negative 2 times m times r times square root of m squared plus 1, that is the coefficient of the x term. So negative b plus or minus square root of b squared minus 4ac. Now in this case, what is a? I mean what is the coefficient of the x squared term, that is 1 plus m squared, and what is the constant term here, that is r squared times m squared. And if we simplify this a little bit, it is going to look like this. And if you carefully look at it, in the plus or minus term there, the quantity inside the big square root is actually going to become 0. So the value of x is going to look like this: negative 2 times mr times square root of m squared plus 1 over 2 times m squared plus 1. And if we simplify that, the 2 in the numerator and the denominator are going to cancel out each other. So we are going to be left with negative m times r over square root of m squared plus 1. So we have found the x coordinate of the point of contact for this tangent line. That means we are talking about the point P from the original diagram. This is the x coordinate of the point P. Now let's try to calculate the y coordinate. Well, let's use this value of x in the equation of the tangent line. Well, the equation that we took was was y equals mx plus r times square root of m squared plus 1. Now we are going to plug in the value of x in this equation and then we'll calculate the value of y. So if we plug in the value of x, then y value is going to look like this. And now we are going to simplify that a little bit. We can write it like this. And if we simplify that a little more, the value is going to look like this. It will be r over square root of m squared plus 1. So this is the y value for the x value that we calculated earlier. So then let's write down the coordinates of the point of contact P. Its coordinates can be written like this: negative m times r over square root of m squared plus 1, that will be the x coordinate, and the y coordinate would be r over square root of m squared plus 1. And using the similar method, we can easily calculate the coordinates of Q. I am not going to do the derivation, I am going to leave that to you to try, but use the exact same technique. Simply use the y value as mx minus r times square root of m squared plus 1, because you want to use the equation of the other tangent line. Here we are trying to find the coordinates of the other point of contact, which is the point Q, and for that you have to use the corresponding equation of the tangent line, and if you use that, you should be able to calculate the x coordinate and the y coordinate of the point Q exactly following the same steps. I have made a note up above here. If we take the equation of the tangent line as y equals mx minus r times square root of m squared plus 1, then the coordinates of the point Q will be like this. It will be mr over square root of m squared plus 1, that will be the x coordinate, and the y coordinate will be negative r over square root of m squared plus 1. So if you carefully look at the x coordinate and the y coordinate values of the point P and Q, you will see that for P, the x coordinate has a minus sign and the y coordinate has a plus sign, and for Q, the x coordinate has a plus sign and the y coordinate has a minus sign. So if we combine these two together, we can write it like this. Coordinates of the points of contact can be written like this: minus or plus m times r over square root of m squared plus 1, that is the x coordinate, and then the y coordinate would be plus or minus r over square root of m squared plus 1. So when we take minus sign for the x coordinate, we have to take plus sign for the y coordinate, and when we take plus sign for the x coordinate, we have to take the minus sign for the y coordinate in the numerator, of course. So this is the combined picture of the coordinates of the points of contact. That brings us to the end of this video. I hope everything made sense. Thank you for watching. See you in the next video.